So guys, in this video, I'm going to be going through the practice problems on page 6 and 7. I think that's plenty of practice for you, and if you can do all of those, you'll be great as far as naming ionic compounds and writing their formulas. So I'm going to go through a number of them. I'm not going to give you all the answers, but I'm going to explain a number of them. Alright? So I'm going to just go through the odds right now through each of these columns and just do a couple and explain them and make sure that we're on the same page. Okay? So let's go through barium sulfate. Now the first steps that I'm going to do, if I'm given the name, I know I have to write the formula. Alright? So I always have to first write the charge. So I'm going to write barium, and I know barium has a 2+ charge. Alright? If you're uncomfortable with that, go back over the charge practice and make sure you're comfortable with that. Then sulfate, what you should realize is it's not a normal element, it is a polyatomic ion, which you have to memorize, I'm sorry, but it's SO4 and it has a 2- charge. Alright, so now what I'm going to do is I'm going to take my handy dandy pen and I'm going to cross my charges. I'm going to put the 2 as a subscript for SO4 and this 2 as a subscript for Ba. Okay, so what I can rewrite this as is Ba2SO4. Now, the important part, guys, the really important part is that you put parentheses around your SO4 before you put the subscript 2 so that the 2 is applying to your entire SO4. Alright? Now, what you should recognize is the fact that since you have 2 2's there, you can simplify it, and in fact you must simplify it or else you're going to get points off. Because this ionic compound doesn't exist as Ba2SO4-2. That's the only issue with my crisscross method, which I think really makes your life a lot easier, except for this one issue. So I'm going to highlight these 2's because they're in common, and so what you want to do, instead, get rid of those 2's, and so what my final answer will be is Ba2SO4. Notice I got rid of my parentheses because I no longer have a subscript. Alright? And I'm done. Okay? So BaSO4 and you're done. Cool? Alright, let's go to number 3. Aluminum nitrate. Aluminum is a +3 charge, so Al3+. Nitrate is one of your polyatomic ions, which you have to memorize. NO3 with a -1 charge. Okay? You're going to cross your charges, so you're going to put the 3 as a subscript for NO3, the 1 for a subscript of Al. Alright, and what you end up with is Al NO3, and remember you have to put parentheses around your NO3 or else you'd end up with NO33 for your, and you'd have 33 oxygens, which you don't want. You just want 3 nitrates. So I'm going to put a 3 around my nitrate and I'm done. Okay, I don't think it's too bad. You just have to make sure you're comfortable with your charges and your polyatomic ions. Alright, I am going to skip down because I think a lot of these are kind of repetitive, and I'm going to go to barium bromide, number 22. Okay, so I'm going to explain number 22 right here, barium bromide. Okay, barium has a +2 charge, so 2 plus 2, whichever way you want to write it, I don't care, as long as you have the plus sign there. Okay, bromide has a 1- charge. You can either put a minus, a 1- or a -1. Either way is perfectly fine. Okay, now I'm going to cross my charges. I'm going to put the 2 as a subscript for the bromine and the 1 for a subscript of barium. And so my final answer will be barium Ba, Br2, and I'm done. Alright. I will do one more problem with you guys. Alright. For 25. Okay. Notice for 25 I didn't give you the charge of silver even though it's a transition metal because I told you Ag always has a +1 charge. Okay, so that's one of the funky ones you just need to get familiar with. Hopefully this amount of practice will help. So Ag has a +1 charge. Okay. Sulfite. Here's the only challenging part about this. Remember, sulfide, if it's IDE, then you should look at your periodic table and put sulfur as an anion with a 3- charge. If it's sulfite, then it's SO3-. Sulfate just means you have one more oxygen. So this is sulfite, so I'm going to write SO3, 2-. Okay? And then I'm going to cross my charges. I'm going to put the 1 as a subscript for SO3 and the 2 for a subscript of Ag. Alright, and I'm sorry they're not perfectly straight, but I hope you guys understand at this point. Okay, so it's going to become Ag2, because that 2 becomes a subscript for Ag, and SO3. I'm not going to put this in parentheses because I don't have a subscript for it, because you don't need to put the 1 as a subscript anymore. Okay, and I'm done. Alright, let's go to naming really quickly. I'm hoping that this will be really easy at this point, so I'm only going to do 1 or 2 of them. Okay, let's start with the top of them. The only challenging part, okay, naming the first one's really easy, it's just the name of the element. The second part, if it's just a plain element and not a polyatomic ion, that is the only challenging part. You have to add IDE to the end of it and get rid of the ending. So for example, this is chlorine. You want to get rid of the ene part, I-N-E, okay, and you're going to put IDE in it as instead. So IDE replaces I-N-E. So all you're going to write for the name of this is zinc chloride. And you're done. Okay. Na2SO3, ignore the subscript unless it is for a polyatomic ion, because that defines what type of polyatomic ion you have. So Na is still sodium no matter what subscript it has. SO3, the 3 does matter because that tells you it's sulfite instead of being sulfate. So it's sodium sulfite, and you're done. I think naming's pretty easy. I'm hoping. Alright, now notice for zinc, I didn't put a 2 for the Roman numeral, okay? Technically you should, and I can put a 2, but I actually know the charge of zinc, always. Zinc is always a +2 charge, even though it's a transition metal, okay? So remember, in chem you always have a couple of exceptions to the rule, this is one of them. You can put a Roman numeral 2, guys, I don't care, I won't take off. Alright? Now let's go really quickly to naming and writing with Roman numerals. Now, as you notice, some of these are not Roman numerals, and in your warm-up, I didn't put Roman numerals with them because I didn't think to. The reason why these have Roman numerals is because lead, for example, we would expect it to have a +4 charge. So, for example, lead, a couple of the others that, I'm trying to think of another one that isn't technically, I believe tin. Let me grab out my handy-dandy periodic table. Lead is a group 4 metal. Tin as well. Since they're +4 charges, plus or minus 4 charges, since their charge is unsure, we put the Roman numeral just to let you know what the charge is, to make it clear. Alright, does that mean that you need to put the Roman numeral? Yes, please. I'm sorry we didn't do it in the warm-up. I purposely had you doing Roman numerals with the warm-up for transition metals, but you also need to do it for your group 4. Okay, so mostly it's just going to be PB and SN that you'll have to deal with. Okay, so for group 4, since the charge is unsure, treat it like a transition metal. The only transition metals that you don't have to write Roman numerals for, you can though if you want to, are Ag and zinc. Alright? Okay, let's work on this. Iron 2, that 2 tells me I have a 2 charge, and since it's iron and iron is a metal, it's going to be a 2+ charge. So I'm going to write Fe 2+, that's my charge of iron. Alright, and sulfide, IDE, remember IDE tells me it's an anion. Sulfur is in group 6, which means it has a 2- charge. Okay, and so what I'm going to do, I'm going to cross my charges. I'm hoping at this point, guys, you recognize, since it's Fe2S2, I can, instead of writing Fe2S2 and then reducing it, I can just write FeS and be done. Alright? Okay, let's go to the next one. Copper 1 oxide, that tells me that my copper has a +1 charge. So Cu1+. Oxide, that tells me it's oxygen, which has a -1 charge. Sorry, -2 charge. Okay, I'm going to cross my charges, so the 1 becomes the subscript for oxygen, 2 becomes a subscript for copper, so it will be Cu2O, and I'm done. Alright? Very doable, and in fact, I'm handing you very nicely the charges of all your cations here. Okay, the only thing you have to figure out is the charge of your anion. Alright? Alrighty. For this part right here, guys, FeSO4, since iron is a transition metal, here's a challenging part. You have to determine its charge. Alright, so let's look really quickly at SO4. SO4 has a -2 charge, which means iron has a what charge? If your entire ionic compound has to have a charge of 0. +2, I'm hoping you're saying, right? +2, -2, they cancel each other out. So when I write the name of my ionic compound, it's going to be iron. I'm going to put in parentheses, since it's a transition metal, 2, okay? And then it's going to be sulfate, because it's SO4. And I'm done. Okay? Let's do the next one, because I think it's a little bit challenging, but you guys can do it. I know you can. Okay? NO2. Okay? We know that has a -1 charge, but here's the challenging part, guys. You've got 2 of them. So this entire NO2 contributes a -2 charge. This is -1, but there are 2 of them. So it contributes a total of -2. Okay? So that's -2. What does the charge of Cu have to be? Okay? It's got to be +2, right? Just as before. Okay, so this is going to be copper, in parentheses, Roman numeral 2, and this is going to be nitrite, because it's 1 fewer oxygen to the nitrate. Nitrite. And you're done. Alright? So work on these. Okay? When you get to the mixed ionic compound review, we're going to do this in class so that we can really talk through it, because you actually have to really be on your toes, recognizing what's a transition metal, what's not. Okay? But it's totally doable, and you guys will be fine. Alright? But get through all page 6 and up to the mixed ionic compound review. Alright? Good luck, guys.